Hey, good morning, everybody. Happy spring day. This is Dr. Heldman. This is Tech Talk Education. And today I want to talk about how the bad guys, i.e. hackers, try to use DNS to exploit computers. It's a pretty interesting discussion. It can get, of course, heavily detailed. We're not going to go quite that deep, but I do want you to have an understanding of, if you're a bad guy, how you think about DNS and how it might bring some juicy things to the table for you. So let's get started. Should be pretty interesting. Now, you'll probably recall from a previous movie that I've made that DNS stands for Domain Name System, and it's essentially the Internet's phone book. So what we do is we have to get to a machine by IP address. We query a name because names are easy for us to remember. We get a number, and then we go and we hit the computer. Now, DNS uses UDP, so there's no actual keying of a username and a password. We just get there using UDP rather than TCP. That's why it makes it so interesting for hackers. You should be aware and remember that there are 4 basic types of caches. Your browser has a cache, your operating system has a cache, your ISP keeps a cache, and if you have any recursive resolvers, they will keep a cache as well. And you should keep in mind that we have some main terms that we want to use. So we have what's called a resolver. A resolver is a machine that gets you the IP address that you need, either by consulting its local cache or consulting other servers that will give it the answer to the IP address that you're looking for. We also have what's called a top-level domain. We have root-level servers that are responsible for different areas of the internet, and then we have authoritative servers that are authoritative for a given domain name. Now, if we wanted to ping somebody, for example, let's go in here and ping google.com. Notice here that I'm not pinging www, I'm just pinging the native Google domain name here. And let's see what happens if I ping www.google.com, if I get a different response, and I do. So you can see that google.com is listening on 217.142. So it's interesting to me that these Google addresses are Class B public addresses. There's 2 things we have to be concerned with: what class the address is, and whether it's private, meaning it's reserved and it can only be used on a private network, or it's public, in which case, of course, this is public. But look at this. Now, www is listening on 176.4, whereas google.com is listening on 217.142. And if I ping mail.google.com, let's see if we come up with something like that. That's 116.83, and then of course if we pinged something like drive.google.com, we'll get even a different address. So you can see here that even though I've got different IP addresses, I've got 142.50, 142.50, 142.251, 142.251. I was saying 50, it's 250, 142.250, 142.250, 142.251, and 142.251. The addresses are all different for these different domain names. So that's something you've got to keep in mind. We're going to check the DNS resolver servers. In this case, Google, of course, is its own authoritative DNS servers that respond to this. And then we get the address back. And these addresses vary by the type of domain name that you're putting in there. Now, so that is one thing that we want to know. We want to know how to Google these, how to ping these different addresses. Also, we want to know what's inside our browser cache. Now, in Windows, it's relatively easy. I'm going to clear the screen here with a CLS command. And you do just an ipconfig space/display DNS. This is going to show your local Windows browser cache, and this can be fairly extensive. There's quite a bit going on here. I have a lot in this cache. So what would happen is I would get done viewing all of this, I would go up through there and look and see if I have stuff in there that doesn't look very legitimate to me. And so some of the stuff is pretty interesting. Like here's this cappy.conatix.com. It's a CDN, content delivery network, that Cloudflare is managing. I've got office.com. I wouldn't know that it was office.com by looking at this huge number here, except that I have this measure.office.com thing. I use the Brave browser, so I have Brave here. Here's another CloudFront.net thing coming from the updates.brave software. I don't know what OSCP2 is, .globalsign.com. You could go out and actually use your browser and find these sites and see what it is that they do. A lot of this stuff is handled through just different resolvers that are getting you where you need to go. Microsoft used to have a server called SharePoint. It looks like it's still alive out there, and it's doing some work here. And I have no idea what this TACRT SharePoint.com, I don't know what this is. I would probably go out there, try and look that up and see if I can get any information out of it. You get the idea. So this is a really, really good way of seeing what it is that you have cached. Now, if you wanted to get rid of the cache, you just want to get rid of it and start over, which I think is a pretty good idea because you can see that it can get quite big. What you do is you, instead of saying display DNS, you say flush DNS. And what that'll do is that'll get rid of the DNS cache on your browser or on your command prompt. Now, Linux is a little bit different. What I've done here is I've opened up Oracle VirtualBox, pfSense, and I'm just running a Debian 12 environment from a series of movies that I did regarding Linux clustering. And this is a good way to talk about the way that Linux works. Now, Linux, it can be using what is called the Name Service Caching Daemon or Daemon, NCSD, or it can use systemd. So depending upon which one your Linux environment is using, you have to find that out first. So what we'll do is we will grab a command prompt here and take a look at that. So I'll bring up the prompt, drag it over to the middle so it's a little bit easier to see. And then what I'm going to do is I'm going to type in a command that shows me PID1. Now you're looking for process ID number 1, PID number 1, and here's how you find that. So all you do is you type in PS, a space, and then aux. And that's the command you're using. And what you're looking for is you're looking for the PID right here. So this is your PID. And it says that it is not using NCSD. It would say NCSD if I were using that. So it's looking at sbin init, and this is my DNS methodology that I'm using here. And so I know that I am using systemd rather than NCSD because it would say NCSD if I was using that. But another better way to find out what's at PID number 1, that's our interesting target. Our process ID of number 1 is telling us in Linux how we are doing DNS resolution. So we go to PID number 1, and that tells us how we're doing DNS resolution. Now there's another command that's very useful for this, and it gets you where you need to go a little bit quicker. So you type in process, then you put in no headers, tac headers, then you tell it that you want to look tac-o, com1, and what this will do is just report back the PID number that you are currently using, and it says that I'm using systemd. Now systemd is used in Ubuntu, for example, starting with 20.10, Fedora 33 or later, and so systemd is a likely culprit for us. It certainly is the case here. We know that, for example, Ubuntu uses Debian Linux, and we are using Debian 12 here, which uses Debian Linux, so we could expect that systemd would be a throwover for us here. Here's what we have to do. So we have to type in a command. It's not as easy to get things done in Linux, partially because there is no OS level caching. So in order to look at this cache, we enter a command like this. What we're doing is we're typing in sudo. We're going to go out and have it write, grab things out of the journal. So it's keeping an online journal. It's a real-time journal is what's happening here. We tell it that we want to get this guy here, systemd resolved, and we want to put it into dnscache.txt. And when I run that, if I do an ls out here, there is dnscache.txt here, and then we can look at it, probably using the less command. So if I do less, less space ~dns-cache.txt, let's see what we have in here. I don't have any entries in here. Another way to do that would be to, an easy way to find out if I have anything in there. I can do an ls. I see that I have dnscache.txt sitting out there. If I cat it, that's an really quick and easy way to see if I have stuff inside there. Let's see, cat DNS cache. Oh, I did a .txt is what I wanted. And it says no entries. But that's the way that you establish if you have anything inside your cache within Linux. Now on the Mac, I don't have a Mac, but I'll explain the instructions to you. You open the console application, you type in any:\mdns responder, and it will show you the cache inside Mac. So there's different ways of doing different things with regards to the DNS cache. Now clearing the cache, I'm going to go back to Windows here. Clearing the cache is handy if you suspect that you have DNS poisoning going on. What does that mean? Well, it means that I set myself up as an answer. So you come query me and you say, hey, is this your IP address? And I say yes, but I'm really not that host. I'm not the device that you're trying to connect to. What's happening is I am poisoning it, and I am spoofing it, and I am directing you to somewhere else than you think you're really going to go. If you suspect that that's happening, you could do a flush DNS. The only complication that this really brings is as you're using, your browser and stuff like that, that you can, you'll have to build this cache back up. But I'm going to go ahead and flush this here just to show you how quick it is. Super quick. Boom. That's it. Very easy. Well, now what happens if we want to clear the cache inside our browser? Because remember, we have an OS cache, which we just used. We did flush DNS, and that cleared the OS cache. Now we've got this browser cache we need to look at. I'm using the Brave browser, but it is a fork of Chromium. So let me show you what you do. So you type in Chrome: //netinternals/ #DNS. What that's going to do is bring up a DNS resolver tool here, and it says, oh, host resolver cache, clear the host cache here. That would be how you would do that, and it also gives you a tool to look this up. But notice here that since I'm using the Brave browser, it saw that I had keyed in Chrome, and it substituted in Brave in place of that, but it brings up the same idea. Why? Because Brave is a fork of Chromium, but it's in some ways a lot more secure than Chrome is going to be. And then there are ways of doing this in Firefox, which I don't use, and Safari, which I don't use, which is for the Mac. And I'll put the instructions below in this movie on how you can clear the browser cache. But that's clearing the browser cache for you. Okay, so now why are some reasons that you'd want to clear your browser cache? You suspect that DNS is being spoofed. That is a time when clearing the OS cache, clearing the browser cache is a good idea, because let's say that you're in, for example, a Starbucks, and somebody is running a rogue DNS server inside Starbucks. They're on the same Wi-Fi. They could be spoofing Starbucks' DNS, and you sitting there with a tablet or whatever could be trying to resolve a name, and you're actually hitting their DNS box. That's an idea of spoofing or cache poisoning. The idea there then is what we want to do is we want to just get rid of that. We want to watch out. If we suspect that we're being spoofed in some way, clearing these caches is a good way to do that. If you're receiving 404 errors not found, that's a good way to do that as well. If you see outdated information, we can understand that maybe DNS propagation, the idea of getting changes pushed through, hasn't worked effectively for you, and you're still showing something in the old cache. Another great reason to frequently clear the cache is because you just want to maintain your privacy. If you let this stuff build up and up and up, at some point you get to where you've got a really large cache entry and you have no idea who's in there, and you have to periodically go in and look at it and clean it out. So I would recommend, and I don't do this very often, so this is me talking to me diagnosing me, probably should consider flushing these caches a lot more regularly than I already do. One thing that you need to know about DNS is that there are different what are called record types. So you'll be looking for DNS records. There are several types of them. Here are the main ones. You should be aware that when you're working with Windows Server, there are going to be some other DNS records as well. The basics are an A record is for IP version 4. And so every node that has an entry in the DNS database is going to have at least an A record. You should be aware that there is a quadruple A, quad A, and that is for IPv6 addresses. I had a student who failed an exam. He was very, very close, but he did not know what a quadruple A record was, and that was the cutoff for him, so he was really bummed out. CNAME record stands for canonical name. What that means is that we're aliasing one domain name to another. For example, like www.example.com goes to example.com. An important one is called an MX record. It stands for mail exchanger. What it indicates is that this IP address is functioning as an email server, and that's a very, very important thing, especially in the hacking world. We're always interested in getting into these email servers. Also, if I have a server that's an actual DNS server, it gets what's called an NS record. It stands for name server. There are text records that can be added just to provide text for some purpose. There is a very, very important record called the SOA, Start of Authority. And what this means is that this is information, admin information about this particular domain. This is the starting point for DNS, this particular record. Whatever machine holds this has the SOA record. That's sort of a top level guy. We talked about PTR, stands for pointer. What that does is resolve an IP address to a domain name. That's very handy, and you can use a command NSLookup to utilize that. There's a service record, which denotes different services like voice over IP, VoIP, etc. And then there's a relatively new record. It's called the CAA, the Certification Authority Authorization. What that's telling you is which certificate authorities are permitted to issue SSL certs in this particular DNS infrastructure. So those are your records. Now, let's look at how to use these records. I'm going to go back to Linux here, and I want to show you how to use these records to do what you need to do. Let's talk about different Linux commands. One is called dig. You might have to install it, but if you just do man dig, it'll tell you if it's installed or not, and mine is, so I'll do a Q to quit and get out of there. And what we're going to do is look for certain records. So I'm going to say dig, but what I want to do is I want to dig google.com, which I totally misspelled, and then I'm going to look for all A records. So the concept of knowing these records is very, very important to you, because you've got to know what you're looking at when you're actually seeing a record inside DNS. And it brings back several records here, and there are the IP addresses. These are all A records. Let's try another one. So I'll clear the screen. I'll hit my up arrow. Let's see if we can find any mail exchanger records. And there's one out there, smtp.google.com. So SMTP is the Simple Mail Transfer Protocol. And what this is responsible for is doing email. So we found an email. Let's look for SOA, see if we can find one of those. You get the idea. So the concept here is that you are querying servers to get information about what sort of records they might contain. Let's see if there's any quadruple A records here. There's likely to be a bunch. Yeah, and there they are. And there's the IPv6 addresses for Google. So that's the concept with the command dig. Now I'd like to point out that dig is not available in PowerShell or in the Windows command prompt, so this is going to be a Linux only thing. However, a command that will work for you in Windows as well as in Linux is going to be a command called NSLookup. So let's do that. So it's ns name server lookup, and then you just tell it what you want to look up. So let's look up google.com, for example. We hit enter, and we get a bunch of authoritative, non-authoritative answers for Google, and that's the IPv4 and IPv6 addresses that we got earlier. These are all A records that were returned. Let's see what happens if we look up just www.google.com. So we'll do this, put the www in front, and it returns something slightly different. I guess it's about the same thing, isn't it? That's because there's a CNAME alias going on here. What about if we do, let's try smtp.google.com, because we hit that before. Let's see what we get. And we get return of some other addresses. So we're getting basically all the same thing here. Now we don't have to use Google's 8.8.8.8. You can see here that it's looking at port 53, which is the default DNS port. We don't have to do that. What we can do is we can tell it, I want to do NSLookup, and I want to look up google.com, but I don't want to use Google's DNS servers. Let me use Cloudflare servers, for example. I'll do 1.1.1.1. Let's see what happens. Now it's out there querying Cloudflare to see if we can find any problems or any things having to do with Google. Not so much. Timed out, it says. And let's try 9.9.9.9, which is quad 9. See if we get any responses there. And we do get a response for Google from quad 9. So you can supply other DNS addresses in order to get what you're looking for here. Now if you just natively type in the NSLookup command like this, you're going to get a prompt here, and the prompt is going to wants to have information. So you're going to give it a bunch of information about what you're wanting to query. So let's do this. So I'm going to set the type to MX. So we're going to do an MX record. It can be lowercase. Hit enter. And now we want to tell it what to go look at. Well, let's go look and see if Cloudflare, and I think it's a .net, has any MX servers. And there they are. And it brings back the authoritative answers for Cloudflare's MX mail exchanger servers. This means that it's running some mail exchanger software somewhere. Mail server software is what I'm trying to say. So that's one way that we can use it. If I Control-C out of here to get out of this and clear the screen, you can do it a different way as well. So what you can do is say clear the screen. Very good. We can put it all on one line. So we can say NSLookup. We can put it all on one line. So we can just say NSLookup, for example, like this. Let's look for a type. Let's do name server in this case now. Let's just look for name server. And we'll look up cloudflare.net. Now what we're doing is we're just looking for anything that has a name server record that's affiliated with cloudflare.net. And it brings back name server 1, 2, 3, 4, and 5. Very, very common in the hosting environment where you have the name servers named NS such and such, and they're numbered as well. We can also do a reverse lookup. So if I ping, for example, ns3.cloudflare.net, and I get its IP address, clear the screen, I can see here that my address is 198.41.222.31. What I can do is a reverse lookup on that, so I can say NSLookup 198.41.222.31, and it should give me the host name, and sure enough it does. And it looks a little bit different. Now what it's telling you is it pulled it out of the in-address-ARPA table. This is a database that lives inside DNS called in-address-ARPA. I don't know why it's called that. Doesn't matter to me. It's been around for years and years and years. But look at this, it's putting it in reverse order, so you should be aware of this, 198.41.222.31, and it brings back the canonical name, which is this guy right here. So that's a little bit different name than just ns1.cloudflare.net or ns3.cloudflare.net, for example. So you can query the in-address ARPA database and get host names back if you know an IP address. The reason that's useful is because now you know some names for computers, and if you were doing, say, reconnoitering, you were out there doing reconnaissance on a given bunch of servers for, you know, whatever purpose, this is going to be handy because you can build a table of different servers, their IP addresses, their host names, that sort of thing. So that's why that's very, very useful to be able to use NSLookup to do this work. Now, another tool that you can use in Linux, which you will have to install, is called DNSEnum. It stands for enumerate. Here it is right here. Sudo apt install DNSEnum TACY. I went ahead and installed that. It's pretty easy to use. You just type in DNSEnum, and then you tell it what you want to look at. Let's look at google.com and see what it tells us. And it's basically the same idea. The cool thing about this is it's getting a lot more information, and it's putting it into tabular form, so you can look immediately at what's going on, what's happening here in the Google DNS box. So that's DNSEnum. So it's still running. I'm still getting a lot of information out of this DNSEnum. It's super cool. And you can look and see that these are, you've got some CNAME records here, you've got some A records. You're going to have to know how to recognize these records when you see them. So I'll just do a Control-C to kill this. There's another tool that you can use. It's called Fierce. Let me do this. So I'll do a sudo apt install Fierce. And I'll put a TACY on the end of that. We'll let that go ahead and get done installing. Kill this and come back here. And Fierce, you need to tell it that your domain name, so tac domain is google.com. There we go, and that's working fine now. So that's how Fierce works. Another tool that you can use is called DNSRecon. You'll have to install it, so you do a sudo. Remember that you do an update and sudo apt upgrade. I did this already. I just want to show you the command again. Grade tacy. So I've already done that. That took 30 minutes for this to complete. Then we're going to go ahead and do a sudo apt install. And this is called DNSRecon. And I didn't put a Y on the end of that. Okay, and this is pretty easy to use too. You could always consult the man page. So you could do a man and a DNSRecon just to see what the switches are. The one we want is the TACD there, so I'll quit out of here, clear the screen. I'll do a DNSRecon TACD, and I'm going to tell it to go look at google.com. And it does basically the same things. You're just getting the information compiled and given to you in a little bit different views. This is actually really good. So you might run 3 or 4 of these tools, make a little notebook for yourself so you can validate that what's happening here. Notice here it says DNSSEC is not configured for Google.com. That's very interesting to me. And then you can see that I get some service records here. These would be very, very interesting to me. I'm looking for specific things like here's calendar, you know, that kind of an idea. TCP means that it's a secure connection. So that's some pretty interesting stuff here. So we're getting other sorts of information out of DNS that might be useful to us, and that's why, as somebody who's a professional cybersecurity, for example, you need to thoroughly know how DNS works, how to install it, how to make it happen for you. But you also need to know about these tools and how they work and how you can garner information out of DNS, because that's really attractive to hackers. All right, now a couple of final little notes before we wrap up this video. I just wrote these down on a list, but I think they were pretty intriguing. So why is DNS targeted by hackers? First of all, because of the ubiquity. So the word ubiquitous means everywhere. It's everywhere, all over the place. And DNS is probably one of the most ubiquitous things we have on the planet now. It is rarely blocked, so that's another reason for it. Port 53 is open almost everywhere. It's often overlooked in the security stack, and it has an inherent trust, making it super exploitable. There are some common DNS exploits that you can get interested in and look for. DNS spoofing and cache poisoning, which we have talked about, injecting false data into the resolver cache. So the reason we're interested in that is because we can redirect users to malicious IP addresses. For example, a really common one would be we recreate a bank's website to look exactly like the bank, and then we poison DNS so that when a user hits the bank site, they think that they're hitting the bank site, but they're really not. They're hitting our rogue DNS site, and we're redirecting them to this thing that looks a lot like the bank site, and we're going to get data. DNS tunneling is another thing. We can use DNS queries and responses to exfiltrate data using a covert channel. There are some tools. One's called Iodine, one's called DNSCat2. We can also hijack DNS. It's going to be really difficult in the Microsoft arena, but you can hijack DNS, which means that we redirect DNS requests through a compromised router or malicious DNS servers, i.e. a rogue DNS server. A lot of times what would be involved here would be actually getting into a company, standing up a rogue DNS box somewhere, and then letting it respond. The effect would be things like phishing and credential theft. They have a thing called fast flux DNS. This is very clever. So the idea is that I'm changing these A records very, very rapidly in order to hide malicious hosts. Hackers that are using botnets or phishing schemes might make use of fast flux DNS. There's a thing called typo squatting. This is very, very interesting. So, Google.com, you're not going to be able to get that domain, but you could get Google with 3 O's, GOOOGLE.com, or they give you another example, Amazon with a 0, Amazon.net. This is called typo squatting, meaning I'm going to register a domain that deliberately has a typo in it, and the reason for that is so that I can be malicious about people that get fat-fingered, and then they're directed into this domain instead. And there are ways to redirect users in other ways as well to these typo squatted domains, but that's a very common thing. Reason I would want to do this is I'm delivering malware or credential phishing pages. And then how hackers discover DNS weaknesses. You do this through tools that we've just demonstrated, like DIG, NSLookup, DNSEnum, Fierce, DNSRecon. And then if you can get a zone transfer, that is really good, because now you have the keys to the kingdom. You've got everything, all of the machines, all of the IP addresses. You'll get some stuff you probably didn't want, like Apple phone is going to get an IP address. If I come into the building and I have like an Android phone or an Apple phone, it'll pick up an IP address off of the Wi-Fi servers in that building. That'll show up in DNS, so that's very common. So that is a little bit more about DNS. It's a super interesting topic. It's something that you need to be intimately familiar with and get some experience installing it, how to get into it, how to look at the records, what's going on there. Listen, if you're enjoying these movies, I would love it if you would subscribe to my channel, tell others about my channel. Really enjoy getting comments from you guys. You guys are very good about putting out comments. They're always nice. I appreciate that. And I'm trying to grow the channel, so if you wouldn't mind telling others about it, subscribing to it, things like that. Thank you for watching. I hope this was helpful, and I will talk to you in the very next video. Have a great day.